Hello, welcome to our planet Dafnamero. Dafnamero is named after the Icelandic and Greek words for prosper, Daphna and Evimero. It's about, in scientific notation, 1.962 times 10 to the power of 24 kilograms in mass, which is about 1/5 of Earth's mass, and it is further away from its own star than Earth is from the Sun. It is in many ways similar to our Earth, but the geography of Dafnamero is what makes this particular planet interesting. First, let's talk about the past. Though this is a relatively young planet, there are a few evidences of tectonic movement. Samples of the deep ocean floor show that basaltic ocean crust and overlying sediment become progressively younger as the mid-ocean ridges approach, and the sediment cover is thinner near the top. Stripes of magnetic material in the seafloor also provide strong evidence for tectonic theory. These stripes alternate between those with the magnetic material oriented towards magnetic north, and those oriented in this opposite direction. Seafloor spreading is the mechanism behind this phenomenon. Pressure from the weight of the crust and mantle have compressed Dafnamero's core into a small solid ball of metal. The ball is slowly shrinking as it cools and hardens, and in return making the core of Dafnamero smaller by approximately 1.25 centimeters a year. However, it is anticipated to stop once the core has been completely compressed. Because Dafnamero is still alive, which means that the mantle is still hot and contains liquid magma, the liquid magma is rising and falling inside the mantle with convection via its light. The thick crust offers little room for tectonic movement and is not easily moved by the slight convection of the mantle, although there is some movement. The temperature of Dafnamero's mantle is significantly cooler than the Earth, with just enough heat to allow a semi-solid state. This makes the mantle a thicker substance, and thus density currents are slow. This keeps the volcanic activity considerably minimal in contrast to other planets and other moons as well. Still, Dafnamero's subduction zones make it possible for the planet to remain alive over the course of several million years. Dafnamero has two types of tectonic plates, oceanic and continental. The oceanic plates are the oldest, as they were created before the continental plates had begun to form. There are two continental plates on Dafnamero, Westland and Eastland. Both tectonic plates were formed because of the huge ocean rift called Uskallin. Uskallin was one of the first features created on Dafnamero, when the crust was thinner and tectonic movement was more common. The rift has expelled magma from the mantle onto the crust in two directions, east and west, therefore creating the two continents of Westland and Eastland after billions of years of formation and buildup. As these two continents were being pushed outward, the hardened magma would converge with the oceanic plate, causing large mountains to form that now reside on the oldest side of the continent. During this collision, the heavier oceanic plate would slide under the continental plates in order to create a subduction zone. The oceanic plate would be remelted to be used in the oceanic rift. Although the process of creating more continental crust is considerably quick, more continental crust results in more subduction zones, allowing the planet to continue its recycling pattern. Many of the features throughout both land masses are quite similar, owed to the fact that they were formed at the central ridge, giving the land a virtually symmetrical layout. The oldest edges of the continents have mountains formed from the gathering of layers, and the pressure of the new crust is in an upwards motion. A majority of the internal land is rolling forest hills. The rich minerals of igneous rock allow for the vast amounts of trees to cover the expanse of the land. The newer edge is a taper beach as it descends into the water. Few volcanoes surround its edge of both continents as a result of subduction zones, but the volcanic activity is very minimal owing to the slow flow of lava. Transform boundaries are very rare and none are in large scale. The most notable boundary is the divergent boundary at the ridge and a convergent boundary at the oldest edge of the continents, as they
rock type. The most common rock type found on the beaches and coastlines is intrusive, but mostly extrusive igneous. This is because the majority of the continental crust is formed from the volcanic activity at the ridge that got pushed to the surface over millennia. More sedimentary and metamorphic rocks can be located near the middle of the supercontinents as the rock has undergone more change by that time. The thick crust makes it harder for intrusive rocks to reach the surface, and in most cases there isn't enough heat or pressure for the metamorphism to occur, although the possibility of it all isn't completely. Erosion and weathering. The process of weathering and erosion are quite similar to Earth. The most common The most common form of weathering is root tide due to the large amounts of trees. Oxidation and ice wedging are almost non-existent due to a thick atmosphere which traps a good amount of heat. The beaches are eroded by the water and rainfall erodes a little but not drastically. Winds are at calm speeds and tend to not become violent in most cases. Similar to Earth 200 million years ago, it was predicted that subduction zones will occur in between the oceanic and continental crusts, forming volcanic ranges. When the eruption of a volcano occurs around the edge of the continent and the mid-ocean ridges, small islands may form as well. There is a significant evidence of the seafloor beginning to spread, as Pangaea had this as well. Although the process is significantly slower on Dafnamero, it could be predicted that two supercontinents may eventually collide or split apart. The outer edges will get pushed further from the middle ridge and could result in collisions. The older crust is slightly weaker than the younger and middle-aged crust, and other factors such as erosion could help establish newer features and could break apart slightly easier.